Hello everyone, welcome to Geeks for Geeks. My name is Saurabh Bansal. So let's start today's problem. So today's problem is index of an extra element. So firstly, we will understand the question, then we will understand the approach, and then we will code. Okay, so let's move to our computer screens and start the question. So the question name is index of an extra element. So firstly, let's understand the question. So the question tells that they have given us two sorted arrays. Okay, we have to remember this word that the arrays are sorted of distinct elements. Okay, there is only one difference between the arrays. The first array has one element extra added in between. Find the index of an extra element. So this question is very easy. Basically, they have given us two sorted arrays, and the first array is having one extra element, and there is only one difference between the A and B arrays, is that they have given us one extra element in the A array. So like you can see in this example, the ninth is the extra array, extra element. Okay, now what we have to do, we have to give them the index of this array. So index, what is the index? 0, 1, 2, 3 and 4. So the index at the fourth index, the element is extra, so we have to return the index. So firstly, what is going to be the approach? Okay, so firstly let's understand the brute force approach. So brute force approach is very simple. You have to just write a small loop. Okay, you have to write a small loop in which we just have to iterate on this array. Okay, we have to use on for this part, we have to use one loop and iterate over array, iterate over the array and compare the elements. Just iterate over the array and compare both the elements. Compare the elements. Okay, so like see, if we are on this element, okay, on 2, so we have to compare for this part, so they are same, so we will move forward. 4 is 4 same, 6 and 6 same, 8 and 8 same, then 9 and 10 are not same. So this is going to be our answer. So this is very easy. I'm not going to discuss this approach. Okay, but this approach will give us the time complexity of O of n. But the question is saying that do this in O of log n time. Okay, now how to do this in O of log n time? So as I have already told you that they have given us two sorted arrays. So now if we have listened the word sorted and arrays, then first thing what came into our mind is that we can use binary search. Okay, so binary search, we will use binary search for this, and also the time complexity for binary search is O of log n. So definitely there is going to be, we are going to use binary search over here. So how to use binary search? So let's understand. Okay, let's take the example of a sorted array, then we will see how to apply. Okay, let's take the example 2, 4, 6, 8 and then 9 and 10 then 12. Okay, so this is going to be our A array, and let's take the B array as well. 2, 4, 6, 8, 10, 12 and 10, 20. Okay, so now what we have to do, we have to firstly implement the binary search over this. Okay, so firstly in the binary search what we have to do is we put just start pointer and then we put the end pointer over here. Then what we have to do is we have to find the middle. Okay, so let's mark the indexes as well. 0, 1, 2, 3, 4, 5, 6. So currently the start and end pointer, so let's write the start and end pointer. So start is 0 and end is at 6. So now the mid is going to be 3. So now when we have got this mid, so what we have to do, so firstly let me mark the indexes of the second array as well. So now we will compare the mid. Okay, we will compare the mid. If the mid of both the arrays are same, if the mid of both the arrays are same, then what is going to happen? Then you can assume that if the mid of the elements are same, mid of the indexes are same, mid of these elements are same, then it is that meaning is that the array till this position is same, both the arrays till this position is same. So this is not going to be the answer. So this array, in this part of array, this is not going to be the answer. So we will, what we will do, we will increase the start pointer to mid plus 1. So if both array of mid, A array of mid equals to B of mid, okay, because it is a sorted array, if these are same, then what is going to happen? Then we will increase the start pointer to mid plus 1. Then we will do start mid plus 1. Okay, so now this is going to be the start. So what is the start position? Start is at 4, end is at 6. Okay, now what is going to be the mid? Mid is going to be the 4 plus 6, that is 10, and mid is going to be 5. Now we have done this. Okay, now mid is at this position. Okay, mid is at this position. Okay, now Now these both elements are not same. Now you can assume here that this meaning of this is the mid can lie like here, okay, and this element can also be our answer because the elements are not same. This can also, so we will save the answer as 5. We will save answer as 5, and after saving the answer as 5, okay, we will move. Potentially the answer can be something else as well, so we will decrease the end pointer, okay. So else, in the else part, what we will do, first we will assume that this can be our potential answer, so we will answer as mid, and then we will put the end pointer as end as mid minus 1. So we will put end as mid minus 1, because this can be our potential answer, because this element is also changed, so this can be also our potential answer. That's why we have stored this. So now what is going to happen over here? Okay, let me just do something. Just rub it first so that it can be visible to you all. Okay, now we have put the start and mid at same point. Start and end are at same point. So what is that point? 4 and 4. Now we can see that 9 and the fourth index. The fourth index is also not same. Okay, fourth index is also not same. So now you can see that these are not same. Now answer equals to mid. What is going to happen over here? Answer equals to mid means answer is now going to be 4 and end equals to mid minus 1. And we will put end over here. And as start is greater than mid, as the normal binary search would say, what the normal binary search says, that start should be less than equals to end. And now the end is less than start. So this time the loop will stop over here. And now we have got the answer, that is fourth index. Okay, so this is how we are going to find this thing. Okay, now let's take one more example to understand this approach. Let's say we have something like this: 11, 22, 33, 44, and we have 11, 22 and 33. Okay, so I'm writing just indexes 0, 1, 2, 3 and 0, 1, 2. Okay, now our start pointer is going to be 0, end is going to be 3, and now let's find out the mid. So this is start, this is end. Okay, let's find out the mid as well. So mid is going to be 0 plus 3, that is 0 plus 3 divided by 2, that is going to be 1. So mid is going to be 1. So let's write mid. So we have written mid. So now we will compare the indexes of both the elements. Now you can see over here that mid of these elements are same. That means from so this part of array and this part of array is going to be same. The starting part of the array is going to be same because the elements are same. As this is a sorted array, so elements are same. That means we will increase the start pointer now. We will now put the start pointer to mid plus 1. Okay, so this is how I am putting the start pointer as mid plus 1. Okay, now what we will do, start is 2 and end is 3. So now what is going to be the mid? So mid is going to be the 2 plus 3, 5 divided by 2, that is going to be 2. So mid is 2, so mid is the same. Okay, so mid is same. Now what we will do, we will see that now these both pointers are same. Now the both pointers are same. Similarly, the both pointers are now same. So what we will do, we will put the start as at this position, start at this position, because the array till this mid is same. You can see over here. Okay, that means there is no extra element between these points. Now start and end is at this point. Now we will put 3 and 3. Now the mid is also going to be 3. But here you can see that when we have find the mid, then we are seeing that there is no element. So this will give us error. This will give us error. And also the answer of us is 3. Okay, the answer is going to be 3. So there is something case. So initially we will put the answer index as the length of the last element. So okay, so the index of the last element, what is going to be the index of last element? That is going to be n minus 1. Okay, so this is how we will do the question. Okay, let's move to the code part. So let's now write the code. Okay, so what we will do is, so firstly I will make the start pointer as 0 and end pointer as n minus 1. This is going to be the answer, and also the answer is going to be the last index. Okay, so this is how we have put in the answer. Now while start is less than equals to end, then if, let's find out the mid as well. So mid is going to be start plus end divided by 2. So this is going to be the answer. Okay, now what we have to find is, firstly if array of mid equals to B array of mid, then what we have to do? We have to increase the start equals to mid plus 1. Okay, but we have to check one more thing, that mid should be less than B dot length. Okay, then only we have to check this, because if the mid is going to be the last element of A array, okay, now this is going to give us the error. Okay, similarly we have to put the n minus 1 over here, as we have discussed. Okay, else if what we have to do? Else if we have to, okay, this is can be our potential answer equals to mid, this can be our potential answer, and we have to also find the answer in the previous section. Okay, so this is how we have put. Now let's put return answer over here. Now let's try to run this program. Okay, so I have to put one semicolon over here. Okay, so this is giving us correct answer. Let us write one more case in which the last element is not present over here. Let's do this for this example as well. Okay, so it is giving us correct answer, so let us try to submit it. Okay, so this is how this question is done by us. So thank you for watching this. If you like the video, please subscribe to our channel. Thank you.